The previous lecture we have studied about the proof of the sampling theorem and the types of sampling, and we have concluded that for the proper recovery of the original information signal, the sampling should be done. The sampling frequency should be at least greater than or equal to twice the maximum signal frequency. Then only all the samples will be reconstructed and original information signal will be reconstructed. And if sampling theorem is not followed, there will be aliasing effect which will occur in the output. Now today we will go ahead in the pulse communication and we are going to study the three different type of pulse modulation techniques which are called as pulse amplitude modulation PAM, pulse width modulation PWM, and pulse position modulation PPM. Like sine wave has three characteristics: amplitude, frequency, and phase. And because of that, we have three types of modulation. When we change amplitude, we have amplitude modulation. When we change frequency, we have frequency modulation. And when we change phase, we have phase modulation. Similar to that, in the pulse communication, our carrier signal is in the form of pulses, but our modulating signal is still in the form of sine wave, and that is why the pulse modulation techniques like PAM, PWM, PPM comes under the category of analog modulation technique. How we define that modulation technique is analog or digital? We define based on our information signal. So if our information signal is analog, then modulation technique is called as analog modulation technique. And if modulating signal is digital, then modulation technique is called as digital modulation. So in our pulse communication, our modulating signal is still analog. We will be taking sine wave, but our carrier signal is in the form of pulses, and pulses have three characteristics. One is amplitude, second is width, and third is position. So when we change amplitude of the carrier pulse, that time it is pulse amplitude modulation. When we change width of the carrier pulse, it is pulse width modulation. And when we change position of the carrier pulse, it is pulse position modulation. So we will begin first with the pulse amplitude modulation. So the definition is, it is the process in which amplitude of the carrier pulse strain is changed in accordance with the instantaneous amplitude of modulating signal, keeping width and position of carrier pulse strain constant. So in pulse amplitude modulation, we are going to change amplitude of the carrier pulse in accordance with instantaneous amplitude of modulating signal, keeping other two characteristics, that is width and position, constant. So this is the definition of PAM. So these are the waveform for PAM. This is our original information signal, that is our message signal, which is still analog sine wave. Our carrier pulses are in the form, carrier signal is in the form of pulses. You can clearly see the frequency. This frequency is 1 kilohertz. This frequency is 8 kilohertz, which is much greater than twice the modulating signal frequency. So that is how the sampling should be done. And this is our natural pulse amplitude modulated signal. We have come across this kind of waveform during the natural sampling. So this is the naturally sampled signal, and this is called as pulse amplitude modulated wave. Now how the natural sampling is done? The natural sampling is done with the help of chopper. So you are having a message signal, and the chopper means it is nothing but a switch whose speed will be controlled by a sampling signal. So when the sampling signal is at the lower position, that is when it is 0, that time the switch will be open. No signal will be passed through the output. When the sampling signal is going to 1, the switch will be closed and modulating signal will be passed through the output. So frequency of this particular switch, which is called as chopper, is controlled by the sampling signal, and this is how the natural pulse amplitude modulated signal will be generated. So this is our message signal passed through a switch, and then it will be generating the PAM signal. The speed of this means nothing but the sampling frequency will be controlled by a sampling signal, and this is called as natural PAM signal. The second type of PAM signal is called as flat top PAM. Now in the flat top PAM, only a one block is appended apart from the natural. So natural sampling may you have only chopper. The speed will be controlled by a sampling signal. In the flat top PAM, you are having one block which is sample and hold, which will be connected here and which will be appended here. So now your message signal is first going through a sample and hold circuit, followed by that it is going to a chopper. Again, the speed of the chopper will be controlled by the sampling signal, and what you have is the output is the flat top pulse amplitude modulated signal. And this flat top signal is coming because of the holding device, means nothing but the capacitor which is present in the flat top PAM signal. One more diagram which we can see for the flat top PAM signal is this, wherein you can see there are two FETs, G1 and G2, one connected in series which is called as sampling switch, another is connected in parallel which is called as discharge switch, and parallel to this a capacitor is connected which is acting as a holding switch. So G1 will be acting as a sampling switch, G2 will be acting as a discharge switch, and capacitor will be acting as a hold element. Now what will happen when the modulating signal comes? When the modulating signal comes, that time initially the supply will be given to, means G1 will be triggered, means G1 FET will be on, and the sampling switch will be closed. The modulating signal will pass through this and it will charge the capacitor. At that time when the sampling switch is on, the G2 will be off. So charging the capacitor means the amplitude will reach to the maximum point where the modulating signal is going. Now once the modulating signal is reaching to the maximum point, the G1 will be switched off and G2 will be turned on, and what will happen during that particular period, the capacitor is going to discharge. So between this particular peak and the discharging period, there is a holding period, because in this particular period G1 is also off, G2 is also off, and capacitor is not finding any charge for any path for discharge, and because of that you are getting flat top PAM. So once G1 is on, capacitor will charge to this particular point. At this point G1 will be off, G2 will also be off, capacitor will be holding the charge. Now at this point G2 will be turned on, and because of that capacitor will discharge. So capacitor will charge through G1 and it will discharge through G2, and therefore this G2 is called as discharging switch. So during this particular period when the amplitude is reaching to peak till the capacitor discharges, it is holding the charge. You can see everywhere it is holding the charge, and because of that you are getting tops as flat, and because of that this is called as flat top PAM. Now if we see the demodulator for pulse amplitude modulation, it is very simple. Whatever signal which we are getting, PAM signal, that has to be passed through a holding circuit. Holding circuit will identify the peaks. Now if you see holding circuit, it is identifying the peak because it is charging to that particular peak. So holding circuit will identify the peak, and once you are getting the peak, you will be passing that to a low pass filter and you will be getting the demodulated signal. If you want to see the waveform, you can see here, this is the PAM signal is given to a switch and a holding circuit. So this is our PAM signal. Now at this particular point it is holding, the switch is closed, it is holding, and then once you are getting the tops of the flat top PAM, then after passing through a low pass filter, you can easily trace your original information signal. Now this particular tracing will be only possible if your sampling is done at an interval greater than twice the maximum signal frequency, then only the all the samples will be recovered properly. Otherwise, the shape of the recovered signal will not match to the original signal. Okay. The drawback of pulse amplitude modulation is the bandwidth requirement for PAM is higher as compared to other form. The PAM signal information is contained in the amplitude, and that is why the interference of the noise is maximum in PAM. The peak power required by the transmitter varies since amplitude is varied in the PAM. So these particular drawbacks are eliminated in the pulse width and pulse position modulation, wherein we are not changing amplitude, we are changing width and position, which we will be able to see in the next lecture.